Hello everyone, this is Holmes from White Box Gaming. I'm the Director of Technology, and today we're going to discuss the fundamentals of .NET Framework. Whether this is your first time writing code or your 20th year, it's always good to brush up on reviewing the fundamentals of the .NET Framework um, if you use it regularly, such as myself. So on our first slide, we're looking at what is the .NET Framework. Well, for me, I view it as a collection of libraries and rules you follow in order to build applications for Microsoft products. I use the term products because Microsoft has a huge suite of products supported by the .NET framework. Most commonly is Windows operating system, of course, but Microsoft does have other .NET, other products that use .NET, and there are also third-party tools such as Unity, for example, that can utilize the .NET framework. It's also important to understand that .NET is an object-oriented programming language, and this means it's not procedural. I mean, of course, you can write procedural functions, but this is object-oriented. It's not designed to be procedural. There's other uh, forms as well, but procedural is the one that comes to my mind. .NET also supports different programming languages, and we'll discuss those in a later slide. So what is a library? Previously, I mentioned the term library. So a library in the programming world is a collection of functions stored in classes for specific purpose. Meaning if you have a graphic library, for example, like you're strictly working with graphics, it only contains functions related to graphics for rendering images on your screen or do something graphical. And that's pretty common when you're building your libraries. You're wanting them to do something very specific or a collection of functions very specific to a certain area. So the most common libraries you're going to see in the .NET framework or that you're going to commonly use are the system libraries. These are libraries that handle exceptions, rules, and other critical tasks related to the framework itself. And they also have other uses that you can use yourself as well. But they're most commonly used within the framework itself. You'll see them also heavily used within the compiler, which you may or may not see that depending on how deep you go into the code. Nevertheless, we'll discuss the libraries in the system libraries in further detail in later tutorials. Just for now, keep it in the back of your mind. Libraries are also something that we build commonly with the intention to export them as a DLL and use in other applications. In case you're wondering what DLL stands for, it's a dynamic link library. A big advantage of the .NET framework is the libraries have the ability to be shared with other applications, which will reduce having to rewrite some same functions of code over and over again. And again, we'll discuss this in future tutorials. So we had mentioned the term class. So a class is thought to be the bones in the body. When you build an application, we think of classes like what forms a skeleton of the application. So like we think of like a human, for example, and like a class would be like one of the bones. So classes commonly store things like properties or objects. So if this is confusing right now, don't worry, we'll go over it more later. Some of these concepts may be hard to imagine until you start writing code. That's a really common thing when you're starting to learn something new that's a little bit frustrating at first. Just stick with it and it'll all eventually start to make sense. So when you instantiate a new class, it'll be null. And you might be thinking, well, what do you mean? So when you declare a new class using the keyword new, uh, everything in that class will be null. Now, keep in mind that's only true if your class contains properties or an object or a value of some sort that you're trying to share. Your classes don't necessarily have to have properties. Your classes could just simply be a collection of functions. So it depends on how you write your class will determine if it's going to have a null value or not, or null values. Generally, though, most classes do contain properties. So what is a function? A function is a procedure or a command-like procedure that must return an object or a value. You can create procedures that do not return a value or an object, and those are called methods. However, a function has a strict rule that it must always return some kind of value. You're going to use functions a lot because they're kind of a building block for when you're writing applications, specifically game development. So when player does X, Y, you want to return Z, or you want it to do this. So if you're doing a health system, for example, like you're taking damage, you need to calculate how much damage that player is going to take. Usually there's an algorithm or something that kicks in. That's a function that you're going to call. So as a best practice, though, I always recommend when you create a function that you always have an input object or value when possible. So meaning that you have to pass something into it. Now, in rare cases, when you call a function, it may not return or it may not require an input value. It may just return something. Again, very rare case. You should almost always set your functions up to where you pass in an object and you return an object. Now, the object can be an integer, it can be a true or false, it can actually be an actual object or a collection of a list or whatever. It can be anything, but you need to always return something. And again, it's always best to pass in something. So that's really important that you understand that. And I believe that concept is also called boxing. And again, there's Google for more information on boxing. I won't go into it on this tutorial. So our section overview, what we've learned so far is the basic concepts of the .NET framework. That a framework starts with a collection of libraries and rules, and then within those libraries and rules, a collection of classes. And a class is a collection of functions and properties. So that's really what a framework is. At a 300-foot view, like at a very high level view. So moving on, the .NET framework is a little bit more complex, unfortunately, other than just some libraries and stuff. There's a little bit more to it than just that. So we typically think of it as having 6 layers. So think of a cake, for example. So on layer 1, we're looking at the language layer. So it supports multiple languages, as we mentioned before, meaning that you can pick a language that you're most comfortable with. I personally use C#, personal preference. It's not the best language, it's not the worst, it's just probably one of the most common right now in the industry, and this is 2020, that could change tomorrow. A lot of people use C#. A lot of people use C++. Those are really common in the programming gaming world industry. In the business world, you're going to see a combination of C# and Visual Basic if you're going to be using .NET. So those are really common. So the common denominator there, if you noticed, is C#. So that's probably why it's the most used currently. The next layer of the application is the applicate. I'm sorry. The next layer of the framework is the application layer. Your application layer can be a console, which is, if you are old enough to remember DOS, That would be like a console-like application where you give it commands. Um, you can have the desktop application, which is probably what we're all most common or most familiar with. This is something that's locally stored and installed on your machine. Um, or you can have a web application. Web applications, again, is something that we're all more and more commonly working with at work. It's not something that you install on your local machine. It's something like where you go to a portal. Other one on here that I didn't put on here that we mentioned later on is mobile. So mobile applications, believe it or not, are part of the .NET framework. Um, for those of us old enough to remember the Windows Phone, uh, Windows Phone is actually supported by the .NET framework, and there actually is an extension for that. However, Microsoft dropped support for the Windows Phone, surprise, surprise, for obvious reasons. However, there's a lot of third-party tools though that still use the mobile apps for that you can use the .NET framework for mobile app development, such as Unity, for example. Again, we'll talk about that in some later slides, but just know that mobile app development is a part of the .NET framework and it is supported. Um, Now it's pretty much supported by third-party tools, not so much directly supported. There's not a direct route because Windows doesn't really have a strong hold in the mobile market currently. I mean, that could change tomorrow. So the next layer, or the third layer, is our data storage layer. This is probably, in my opinion, probably one of the most important layers. So as we mentioned about desktop applications, um, in desktop, you commonly would store your data in XML. Now, we don't really do that anymore. Most people use SQL databases. You may occasionally run into it though, where you see a lot of XML. I've only seen this in manufacturing, and that's just because they're behind the tech curve. Usually, most commonly, people call an API, and then that API calls a SQL database to store your database, to store your data. There's other ways, of course, to store your data. It can be in a text file or whatever. But again, these are the most common ways of doing storage and probably the most secure ways. But, again, there's more than one way to skin a cat, as we say. So, relating this to games, this is when you would probably save your game progress. So, in the olden golden days of non-MMO RPG type games or non-MMOs, everything's saved locally on your machine in a file. Um, some people store it in an XML formatted file and encrypt it. Some people store it in a text file and encrypt it. Some people don't even encrypt it at all. There's lots of ways that you store your data. I personally store it on a database. Even if it is a desktop application, I still have an interaction with our API and we securely store it in our database. However, you may not be that sophisticated in building your apps just yet, or you may have a better way. I mean, there could be something else that emerged since this video, and you might have a better way of doing it. So there's lots of ways to store your data. Just understand that concept, that it's there. The next layer is the assembly layer. We talked about how the framework supports multiple languages. Each languages each language has its own compiler, and this takes your language's code and converts it into machine code or binary. And we'll go into that more in depth in just a little bit. So the next we have the execution layer, and we'll discuss the common language runtime in depth more in the next few slides. You'll start to kind of see the CLR kind of come together. It's very important to understand, but it's also very basic at the same time. And that'll start to make sense like once we go through the framework and understand the pieces a little bit more in depth. And then finally, we have the operating system layer. Typically, we think of this like Microsoft Windows. This is not always the case, though, as I mentioned before. For mobile, for example, you could have an iPhone or an Android, which has their own operating system that may not be Windows. So again, as I mentioned, where Unity, um, you can write your code, for example, in Unity. Let's say you're writing your code in C Sharp. It will compile it, and then it'll recompile it or break it down to where whatever operating system it's wanting to support can read that code. I don't know all the details and how Unity does it, but I'm assuming it breaks it down to probably just machine code, which is just binary, and it reads it that way. And that's probably how it interprets it, because it allows the support of multiple operating systems in different environments. So that's probably what it's doing. And I'm sure somebody's going to hose me on the internet if that's not right. And I'm sure you just check the comments and you'll see my hate mail. All right, so the next thing we want to talk about, now that we understand the layers, in the first layer we talked about the framework supporting different languages. So this is commonly referred to as the CLS, or Common Language Specification. The term itself I think, is kind of self-explanatory into what it's meaning, but you really need to kind of plug that one in the back of your mind if somebody asks you in an interview, what is the CLS? Basically, what that means is that the .NET framework supports multiple languages, and you specify which language you're going to be writing your code in when you start building your application or your project. Next thing is the common type system, and this is on the compiler level. So we discussed how third-party tools such as Unity can compile the code and allow it to work on non-Windows operating systems. Because of CLS, we can also build DLLs, as mentioned, like dynamic link libraries. Sorry, I'm twice. As mentioned previously, they share them, though, with other projects written in different languages and still have access to those functions within the library. This gives you the power to build a very powerful library in C++, for example, and then you can use that library um, in an application that was written in C Sharp or VB.NET, for example. Um, Another thing you can do with this concept is you could have multiple developers writing multiple libraries. They could write them in different languages, doesn't really matter, and then you can import all those into a single application and utilize all those functions within those libraries. So that's a great thing about the common type system. Again, this is a key term that you probably just want to plug in the back of your mind for interviews and things of that nature. But it is also a key factor of the .NET framework and how it works. So basically, the key takeaway here is that because of the common type system, it allows you to basically create universal libraries. So as we'd mentioned before, we talked about the compiler. We never really discussed exactly what a compiler is. Um, when you think of a compiler, it's just simply converts your language code, like what you're writing, into machine code. Your compiler does not understand. I'm sorry, your computer doesn't understand English. So even though we speak English and we write English, your computer doesn't understand it. So you need a compiler to convert or translate your code so the computer can understand it and understand your commands and process it. So the compiler kind of acts as like your translator between your code and the computer. And that's really all it does. So we had mentioned machine code a lot. So machine code is commonly binary. Now I say commonly because You could be working with a quantum computer or whatever. Like, who knows? I'm going to stick with binary because that's generally what you're going to run into. Most machines that I'm aware of are going to be thinking of machine code as binary. Um, as I pointed out here, a great example of a use of binary would be like the ASCII programming. I've never done any ASCII programming, but I know it's all binary based. So if you've never worked with binary, binary is a series of zeros and ones. Um, what this means is typically like in as far as humans are understanding is true or false. Like 0 is false, 1 is true. And this kind of goes back to the creation of the computer. So originally computers are just simply a giant relay switch or a series of relay switches um, that ultimately just are giant calculators. Is what it boils down to. Is it's how we use it. It's just as a giant calculator. And now we've made it this really super complex calculator that can do all these crazy things. But literally at the end of the day, the only thing that the computer understands is true or false, on or off, or 0 and 1, however you want to look at it. And I say on or off because, again, I'm referring back to when I started working on hardware, and we had these things called dip switches. It was literally like a little light switch on the circuit board itself, and you would turn it up or turn it down. Up was on, down was off. Kind of literally like a light switch. And that stood for 0 or 1. And that's how I configured my BIOS. So for those of you who are hardware junkies, you know that a BIOS is a basic input-output system. If you don't know that, don't worry. It's just, computer jargon. I'm sure you'll pick it up eventually in your career. So, as we have learned, the framework supports multiple languages. Uh, this code is compiled and pressed into what we call a managed assembly. So basically, we start with the layer of the language itself. So whatever you chose to write your application in, what language. So I would probably pick C#, for example, looking at this map. And then my code goes into the compiler. And then the compiler goes into what we call the managed assembly level, which we had talked about um, Unity, for example, taking your compiled code or your machine code, and that's how it works with it. It's how it's able to recompile or whatever it's doing with it allows to work with other operating systems. So even though you're working with iOS, for example, you can still write your code in C#, and because of managed assembly, it will be able to decompile it and rewrite it or do whatever it's going to do with it, so your phone will know how to execute it. So I just want to say this with the closing, though. It's important to understand these concepts of the .NET framework, especially when you're preparing yourself for a job interview, or as you move up in the ranks and you're wanting to build bigger applications and you want them to be more scalable. Um, you want more stability and you want to be more efficient and safely build apps. So the better you understand the fundamentals, the better you will be as an engineer in building your applications, your games and whatnot more effectively. There's more to this to the .NET fundamentals, and we're going to go over those in a later tutorial. But for now, this is part 1. So I hope you found it very helpful. And again, this is probably very beneficial for you if you're preparing for a technical interview. All right, thank you.